Now imagine a ball that you're holding in your hand and you're holding it out of the window. And you let go of this ball. So the initial velocity of the ball would be 0 meters per second. Now I'm going to let you in on a little secret. After 10 seconds, its velocity will be 100 meters per second. Of course, it's accelerating downwards. So after 10 seconds, it will be 100 meters per second. But after 1 second, it will be 10 meters per second. So again, we have this case of constant acceleration. So if the initial velocity was 0 meters per second and the final velocity after 10 seconds was 100 meters per second, what is the average velocity? The correct answer is 15 meters per second. So as we saw earlier with the truck, now we know if we drop an object and we hear the bang after 10 seconds, we know how deep the well is. So can you understand how deep the well is? This is exactly as in the case of the truck. Only in this case we have a ball, it's falling and it's accelerating. The initial velocity is 0, the final velocity is 100 meters per second. The average velocity, as we said before, is 50 meters per second, and the travel time is 10 seconds. So the correct answer is, of course, if the average velocity is 50 meters per second and the travel time is 10 seconds, then the length of the well, the depth of the well is 500 meters. That's 50 times 10, 500 meters. And you can make the same calculation for 6 seconds or even 1 second, because the acceleration is constant, and you can say that if the initial velocity is 0 and after 1 second the velocity became 10 meters per second going down, then the average velocity in the first second was, the correct answer is of course 5 meters per second, and the depth of the well, that is 1 second deep. How deep is that? So just as before, our average velocity was 5 meters per second, and the duration of the journey was 1 second. So the depth of the well would be 5 meters in this case. So you drop something, you hear it after 1 second, you know it's 5 meters. Hear it bang on the ground. Okay, so now we know about vertical drops.